The only thing that evolves faster than technology is our expectations. We want everything. Better, easier, now. Suddenly, downloading an app feels like it takes forever. And in many parts of the world, data is still at a premium, with 1 megabyte costing up to 5% of a monthly wage. Let's face it though, until now, the alternative to native apps hasn't been great. But that was then. Progressive web apps can now deliver mobile web experiences with a native look and feel, offering features like real-time push notifications, adding a site to your home screen so you can easily jump back to it with a single tap, even when you're offline. Plus the ability to make quick payments on the go. And all from your browser. This is the next generation of the mobile web. So what are we waiting for? Let's go and build something great.
Thanks for being here, guys. My name is Jad Joubran, and I'm a full-stack teacher in Amsterdam, Brussels, Lisbon, and London. And today I'm here to talk to you about the future of web apps, technically the awesome future of web apps. So that's why we're going to cover progressive web apps from scratch, and we're also going to talk about some best practices. So how many of you are familiar with progressive web apps? All right, keep your hands up if you've done progressive web apps, not necessarily on production, locally. All right, so this is going to take you from zero. We're going to start talking from scratch, and we're also going to cover best practices. And towards the end, I'm going to tell you some web APIs that I'm excited about. Some of them have landed in almost all browsers. Some of them are coming soon in other browsers. And we're going to conclude with the future app model, or what some people believe the future of web apps is going to be in a few years. So let's start by talking about progressive web apps. And the first question that I always get, what is a PWA? Is it like a Chrome extension? Is it like a library, a framework? And a progressive web app is, you can make your website as a progressive web app by using some modern APIs, by using some modern web APIs that will make your mobile website much faster, more engaging, and reliable. So after showing you this nice introduction video, I'm sure you all want to see how it works. So I'm going to show you the independent components of a PWA, so you'll be able to know how to add it to your own web application right now. And the first one is the web app manifest. And the web app manifest is just the JSON file that tells the browser more about your web application. So it describes it. It gives it a short name, a name. This is an example of a manifest.json. So the only thing you have to do is just link to it with the link relationship manifest. And this is a sample of a manifest.json. You give it a short name, theme color, background color, etc. We're going to see how all of these work. So let's take a closer look. If we define a short name and an icon, so normally you define more icons, more screen sizes. I just want to keep the slides short. And here's a video of what happens when the user clicks on the overflow menu and tries to add it to his home screen. So by default, we get the short name that we defined and the icon. And once the user adds it, we get it on the desktop, on the home screen. So just by defining those short name and icon. And now once we have an icon on the desktop, the user can click on it, and this is where the browser is going to open with a splash screen. So you are able to customize the content inside the splash screen. So you can define a name. Now the name can be the same as the short name, or you can define something longer. That's why you have the name. You also have the theme color, background color, and let's see how it works. So when the user clicks on it, we have a splash screen. And the blue color is the background color, and you can see how this theme color is affecting the status bar. So once again, all of this just from this manifest.json. You can also look up the orientation. In this example, I've set it to portrait. Now, all of this magic happens because we have display standalone. Display standalone actually instructs the browser to hide itself. That's why you don't see Chrome anymore. You see Foursquare. That's because I decided to build a progressive web app called Foursquare. And this progressive web app is going to launch a certain URL, which I defined in start_URL, index.html. And once again, you see how the theme color, if I go to this task switcher or app switcher, you can see there's no Chrome or browser or Firefox anymore. This is my own progressive web app that gives the user an immersive experience. And you can see once again how the theme color is affecting the app. So that's it for the web app manifest. It's fairly easy to use, and that's the main component of a progressive web app. Now, the most important component of a progressive web app is the service worker. And the service worker is a JavaScript file that runs, or a script that runs by the browser independently from the web page and separate from a web page. So your page doesn't have to be open for a service worker to run. And this actually lays the technical foundation for a lot of interesting features. Push notifications, the ability to make the app site work offline, the ability to intercept network requests, and also background sync. So let's see how it works. The first step, obviously, is to register a service worker. So first of all, you want to make sure that you only register a service worker if there is support for it in the browser. So that's why we wrap it with if service worker in Navigator, and then we register a service worker. So navigator.serviceworker.register. But you have to pay attention to something here. This service worker.js file, the location for this file actually matters. If you put it inside the scripts folder, then it's only going to be able to access or manage the network requests going outside of the scripts folder. That's why in most scenarios it will be at the root level of your website. And this is a promise, so you can see if it was successful, if the registration was successful, or if there was an error. Now, you're probably wondering what's inside serviceworker.js. It's, of course, regular JavaScript, but we don't have access to the DOM, so you're not going to see the same code you're used to it. We're going to see some new web APIs. So the first step is to listen to the install event. The install event happens when the service worker is installing. And then what we do is we create a new cache called myCache in this example, and we try to add to it all of these static resources: index.html, app.css, and logo.png. So we've got some resources from the network, and we add them to the cache of this page. So nothing happened so far. We just added some files to the cache. So the next logical step is to listen to the fetch event. So I'm going to continue writing my own service worker code. So I listen to the fetch event. The fetch event fires whenever the main page requests a resource from the network. But because we have a service worker installed, the service worker is going to intercept this network request. So we are able to deny this request, but it's not useful. We are able to maybe serve it from the cache. So let's see how we can make that. So we're going to respond with something. First of all, we try to match this request. So event.request. Do we have an entry for this request in our cache? If we do, then response will have a value. So we will return response. So what happens is if we're requesting, for example, the logo, and we have it in the cache, we're going to return it from the cache. And if we don't, then I'm going to use the fetch API, and I'm going to request it from the network and return it back from the network. So that's the most basic service worker code. It works. If you try it, it really does work. But don't go on production. Don't go to production with this kind of code, because it's not future-proof. If you try to remove files, if you try to add other files, you're going to have some kind of bottlenecks. It's not going to be very optimized. And this logic that we're doing here is kind of limited. So what I recommend is to use SW precache. And SW precache is a node module by the Google Chrome team. And it generates service worker code for you, right from a configuration file. So you define which files are considered as static files that you want to cache. So you can pass index.html, app.css. You can even pass a wildcard here to say all the images inside the images folder. And then you just run SW precache, which is the binary, pass in the configuration file, and it will generate the service worker code for you. By the way, I'm going to do a live demo at the end to show you almost everything we talked about, and you'll be able to try it on your phone. So if you don't pick up anything right now, we will get to it later on. So once we register the service worker, if you open Chrome DevTools, you will see that we have a service worker running. So now the difference, what's going to happen, or the benefit, is that previously we used to load things from the network. So I used to load the index.html from the network, same thing for the image, but now we are actually loading it from the service worker. So we are able to load some resources reliably. If we have internet connection or not, we're still able to ship those files, to return them to the user. Even if we have flaky connection, we are still able to display something on the screen. And that's only half of the way for now, because, okay, we shipped something on the screen, but what happens if the user tries to request something from the internet? And that's where SW Toolbox comes in handy. SW Toolbox is another service worker library by Google Chrome. Node module, it's a Node module as well. And it gives us a few strategies to deal with content that is coming from the network. So cache first, network first, and fastest. Let's see how they work. This is cache first. It's fairly simple. We've got a page and a service worker, and this is a network request, the green dot. When the network request gets dispatched from the page, it gets intercepted by the service worker, and then it will decide that, okay, we need to get the data from the cache, so the data from the cache will be returned back to the page. So this is useful if you've got a list of countries, for example, you want to get, and you know you have from the cache. You know you have them from the cache. So you just use the cache first. And if you don't have them from the cache, then the first time you get them from the network, they will be automatically added to the cache. This is cache first. Let's take a look at network first. So once again, the network request gets dispatched from the page, intercepted by a service worker, and goes to the network. Now, the network will sometimes fail. So for some reason, the network has failed. And this could happen for a lot of reasons. So we now backtrack the request to the service worker, forward it to the cache, and get the data back to the page. So that's a nice way, again, to be resilient. I try to load the content from the network because I need to get the freshest content. But in case it doesn't work, I'll just revert or fall back to the cache. And the last one, which is fastest or stale while revalidate, I've got some network request, and it gets intercepted by the service worker, which then spawns two identical requests, one going to the network and one going to the cache. But obviously, the one going to the cache will resolve first and return the data back to the page, whereas the one from the network is going to go and just update the data from the cache. So this is a nice strategy if you always want to return the content from the cache and you don't mind if it's stale content, while always trying to update it in the background, to always have like a kind of a fresh copy. So how do you use them? So you use them in conjunction. So you can say, whenever I'm calling the Yahoo APIs, I'm going to use the fastest strategy, whereas whenever I'm getting the list of countries, I want to use the cache first. So you can define regular expressions, you can define fixed URLs, and like attribute, for this URL, I'm going to use this pattern. And you can even do more complicated things. So for example, you can name your cache and specify a list of maximum entries. You can even specify when those entries will expire. In this scenario, they will expire after 1 day. And you can also specify a network timeout seconds. This is my favorite, because you can say, I want to try and get the freshest content from the API, so orders new, if you want to get the list of orders. But in case it takes too long, in case it takes more than 3 seconds, then I'm just going to fall back again to the cache. So you think about it as if the network has failed. And this actually fights Li-Fi. Anyone knows what Li-Fi is? Any guess? That's when your Wi-Fi says it has Wi-Fi, but it's actually lying. And it does happen a lot. So it's when your phone is showing Wi-Fi and you go to a website and it keeps showing on a blank screen for like 1 minute. So this helps you prevent Li-Fi, because if the page doesn't respond after 5 seconds, you're forcing it to get from the cache, to get the data from the cache. And now you're probably wondering, that's right, okay, I do need SW precache, but at the same time, I do need SW Toolbox. So how can I work with them at the same time? And actually, you can configure SW Toolbox from within the same configuration file that we use for SW precache. So this is what you've used to have before, and I'm going to add the runtime caching. And this is where you can specify URL patterns and the handler. So you can specify as many as you want. You can even pass the advanced options here. And the nice thing about it is once you have a nice progressive web app, the browser will ask your users if they want to install it to their home screen. So this happens automatically and without any intervention from the user. But now there's obviously some criteria behind this. The browser cannot ask you for every single website. So those are the criteria that the website looks for. You should have a valid web app manifest, of course. You should have a registered service worker. You need to be on HTTPS. Actually, service workers don't even run on HTTP for security purposes. And finally, the user has to visit your website at least twice within a 5-minute duration between 2 visits. That's because they don't want to ask the user the first time if they want to add it to the home screen. They have to wait for like at least 5 minutes. So this is really nice for users, but quite challenging for us developers to test. You will have to deploy code, go to the website, take a 5-minute break, and then go back again. So luckily, there is a Chrome flag that allows you to disable this just for you so you can test. So bypass app banner engagements, and you'll be able to go to the website, and the browser will ask you from the first time. And I mentioned that Service Worker opens the door for push notifications. And I want to explain briefly why we finally have access to push notifications. Why can we receive push notifications now? So in this example, Flipkart API has sent a request to the GCM, to Google push notification server. And then GCM is going to send the request to our phone. Now, our phone is going to wake up Chrome, and then Chrome is going to wake up our service worker, even if Flipkart was not running. So that's why we are able to do push notifications, because service worker can run independently from a web page. And now that the service worker is running, using the notification API, we can just pop a new notification, and that's it. And there's also an exciting new feature that's only available in Chrome right now, but coming soon to other browsers, which is background sync. There are 2 types of background syncs. This one is supported on Chrome, which is basically a way to defer tasks until the user has connectivity. So imagine you're building a WhatsApp web application, and the user tries to send something, but they don't have internet connection. This will allow you to send it as soon as possible if you've got internet connection, or just delay execution until the user has connectivity. And once again, even if the web page is closed. And this actually employs an exponential backoff instead of trying every single second. And there's the periodic sync, which is currently being spec'd. So this one is not available in the browsers yet. But it actually allows you to do a periodic background sync. In this example, every 5 minutes. And you can also put some constraints on the power state and the network state. So avoid draining means the user has to be plugged in. And network state, avoid cellular, means that the user has to be on Wi-Fi. And you can just keep the defaults here. So I think the most important question that I'll be getting is, what's the browser support for this? And there's an awesome website to show you the browser support for every single feature. I took a screenshot only of the motivation to build progressive web apps, because without motivation, there will be no progressive web apps. And progressive web apps work on Chrome and Firefox and on Opera. Also, Samsung Internet has a version which works with progressive web apps. So if you've got like an Android tablet, they will work. And Edge is in development. I've heard rumors that it should be available in Q1 2017. Let's hope for that. But actually, Edge is pushing people to build progressive web apps without waiting for them, because if they build it today, and then when Edge rolls out support, it will just work. And Safari doesn't have anything transparent, but there's a brief positive signal about it in a 5-year plan. So it should be coming, but no one really has the answer for that. So now let's take a look at some progressive web apps best practices. Everything I covered so far is the basics of progressive web apps. But once you start building progressive web apps, you'll have some kind of problems or some kind of minor issues. So I'll cover as much as possible and more about user experience best practices to make your progressive web apps much better. And the first best practice is about the theme color. How many of you have noticed that when you go to Facebook, you have something similar to this? Like you have a blue background color. So I originally thought that this is affected by the theme color in the manifest.json. But actually, the browser doesn't load the manifest.json unless it needs it. So if you want to add this background color to your browser, you'll have to do it as a meta tag. So normally what happens is that you put the same color here as the one you have in the manifest.json. I just want you to be aware that the manifest.json doesn't directly affect your website, only if the user tries to add it to the home screen, or only if the browser thinks that they should ask the user to add it to the home screen. And then there's the concept of first paint, which is how much time do we need to start painting in a web browser? So here's an example. We've got two opposite scenarios, one with optimized rendering and one with unoptimized rendering. And this is a scenario that you will see a lot on the web. You open a website, wait for like 5 seconds on a white screen, and then suddenly everything loads. So I'm going to show you a typical HTML file to explain this problem to you and tell you how you can do this setup in a progressive web app. So we've got a CSS file in the head, basic HTML, and we're loading a script at the end. Now, if we open the network tab in Chrome and set up 3G throttling, we can see that we're loading the index.html, the image, the JavaScript, the CSS, and the whole thing takes 5 seconds to load because we are on a 3G connection. And this is where the first paint actually happens in this example. So I want to ask you, what is the browser waiting for it to start rendering? The script and the CSS. It's not very obvious that it's waiting for CSS. But the reason why the browser has to wait for CSS is because if it doesn't wait, then the browser is going to show some content without styles. And then when the styles arrive to the page, it's going to do a flash of unstyled content, which is not a good user experience. So this is like a default behavior by the browser. So how can we unblock CSS and JavaScript? Let's start by unblocking CSS. And the strategy that I like to follow is by inlining critical CSS. So that's right, we use inline styles in the head for the most important bits and pieces of CSS. And then for the rest of the CSS, we just dynamically inject it at the end. So what do I mean by critical CSS? Well, I'm just talking about those minor styles that you can add in the head to just show something to the user. So I'm just changing the background color here to gray, removing the margin, and then just setting a background color on the header. It's not a lot, but just to show that something's happening. And to unblock JavaScript, it's much easier. You just add the async attribute here. If you've got multiple script tags, you'd have to use defer if you want to guarantee execution order. So if you've got one script that is a vendor and the other one that is an app.js, and the app depends on the vendor, you want to make sure that the app has the vendor loaded, so you'd have to use defer, because async does not guarantee that they will run in the same order. So putting it all together, you will have inline styles, regular HTML, async loading for scripts, which also has async loading for styles. And if we put it to the same test, same 3G throttling connection, you see that we now start to render at less than 200 milliseconds. So side-by-side comparison, a huge win, although it still takes 5 seconds because we didn't optimize the whole thing. So why am I stressing on this? Because this is a pattern we see in native apps. When you open Facebook or WhatsApp, in less than 200 milliseconds, you see something on the screen. Whereas when you open a website, you'll be staring at a wide screen, and that's not going to look so native to the user. So let's take it a step further and talk about the app shell. And an app shell is just the minimal HTML, CSS, and possibly JavaScript that powers a user interface. So the app shell is just a way to design your website and to expect content to go inside of it. So what you normally do is just add a nav bar, change the background color, maybe add some cards, and once you have the data loaded, you will just inject it inside of the app shell. So Inbox has an awesome app shell. Anyone uses Inbox? It's an awesome email tool you should use. And in less than maybe half a second, when you open Inbox, you will have a floating action button, snack bar or toast, actually toast, and the header that is painted. So this is a good pattern. And I want to show you that it's not that hard to create an app shell. You don't need a lot of lines of CSS. I have a floating action button again. That's the code for it. I've positioned the logo, changed the background color, and you can build app shells very easily. But you have to take it into consideration when designing. So now for this app shell, we've got some considerations. First of all, it must load fast. We've talked about it, and it must be cached. So it should load fast. This is something we've done using optimized rendering. But how can we cache it? This is also something that we've done using SW precache. So when you added index.html to the list of resources for precaching, now we are able to always render this app shell reliably. Even if we don't have internet connection, even if we have poor internet connection, we are always able to render this app shell as soon as possible. Now, a common question that I get is, how can I detect if a user is coming from my browser, from the browser, or from the home screen? And the answer for that is very simple, but it actually breaks a lot of things. So that's why it's documented here. So you can use the start URL to add a query string. So what people normally do is they add a query string home screen equals 1. And that way you'll be able to read this and understand if your user is coming from the progressive web app or from the website. If they're coming from the website, then they will not have this home screen equals 1. However, this is going to break your progressive web app. Let's see why. Because every URL that you precache, it will be treated as a different URL. So query string parameters will make it look as a different URL, except for UTM parameters. So that's a configuration that was added by default in SW precache. So UTM, anything that starts with UTM underscore will be ignored. So that's why we will have to go and add to the ignore URL parameters matching home screen. Or else what's going to happen is the first time you go offline and the users go to this progressive web app, it's not going to load. Because the browser is going to say, I don't have home screen equals 1 in my cache. And of course, you have to add query string home screen equals 1. And also some developers add slash for development purposes, because if you're running serve, if you're serving, you normally go to localhost port 8000 slash. So slash is different than slash index.html. All right, so now we've taken a place on the home screen, and that's a huge win. But it also gives us a lot of responsibilities. So there are some considerations that we should follow. So I always like to remind developers that we know about progressive web apps, but our users don't. They don't even know that the term PWA exists. If they see an icon on the home screen, then they know this is a native app. At least they think it's a native app, which means it should behave like a native app. So that's why I've been talking about the first paint, app shell, and all of these. But there's a big problem here. Actually, I'm going to talk about the next step after the app shell. So after we draw the app shell, we have the first meaningful paint. And the first meaningful paint happens when we start showing content to the user. This is an important step. And then after it, there's the ready for interaction. Because sometimes you have the content in front of you, but if you click on it, it just doesn't respond. And the reason why this happens is JavaScript. So this is a real trace that I took from my MacBook Pro with only 5 times CPU throttling from nasa.gov. The browser was idle for 8 seconds. Not idle, but I mean processing JavaScript for just 8 seconds. So this is on a MacBook. Imagine what would happen on a phone. And that's only because they're shipping a big vendor.javascript. So in the beginning of the talk, I told you can make any any website as a progressive web app. This is technically true, but if you have big scripts, then the user experience it's not gonna be like the one you want to have. So what's the answer here? What's the solution to this? So obviously don't ship too much JavaScript. I know this is not, like talking to developers, I know this is not an easy thing to do. So I'm going to give you some recommendations. Enable to ship less JavaScript. And the first one is Source Map Explorer. Has anyone used it before? So this is a node module that explains more about the stuff that you're shipping inside vendor.js. So it will tell you what libraries you're shipping, and it has helped some teams to understand why they're shipping jQuery twice. So these kind of mistakes do happen. Or why you're loading the whole Lodash library, whereas you only need 1 or 2 functions. So it's not that smart. It will not tell you can load only those 2 functions. You'll have to make those conclusions. But it will show you that, for example, 10% of your vendor.js is being spent on this particular library. So this is useful. You must try it. And also code splitting is one of the best patterns. Now, of course, if you're using old frameworks, you will not be able to do code splitting. But if you're using newer frameworks, you'll be able to do code splitting. And the benefit here is that for every single page, you will have one small JavaScript file. So for the landing, you'll have landing.js, which is about a few kilobytes. For the settings, you'll have its own settings.js file. You will obviously have like a small common file that's common to all of them. And the added benefit here is that we don't ship a lot of JavaScript. We don't spend time in the network. The CPU doesn't spend a lot of time. And when we have to re-invalidate settings.javascript, we're not re-invalidating the whole app.js. So you only re-invalidate the file that needs to be re-invalidated. And debugging is obviously very important. I always tell people, like, don't expect developers to build progressive web apps if they don't have the tools to debug. So during the live code, I'm going to show you some awesome tools from Chrome. And there's also a Chrome plugin, which is called Lighthouse. Lighthouse gives you metrics, performance metrics, and best practices in order to build progressive web apps. So for example, it makes sure you have a registered service worker. It makes sure it works offline. It gives you metrics for first meaningful paint, first paint, etc. And it warns you if you're using deprecated APIs or if there are better ways to do things. So this is a must try. Like, you will have the brightest engineer, but in a Chrome extension, giving you feedback on how the progressive web app is working. And this is also available as a node module. So if you can set it up in your continuous integration and see if there are any UX regressions. So now I want to talk about the future, and I think the future is promising. First of all, because of progressive web apps, and second of all, because some web APIs that are coming or that are available in browsers. And the first one is passive event listeners. So I will tell you the problem before the solution. The problem is whenever you add a touch event, the browser had to wait for your callback to see if you called event.prevent default before passing it to the compositor, or before actually handling the scroll event. So that's why scroll is slow on all websites, on most of the websites. That's because only they have a touch event. So that was a problem by design. That's why the browsers have solved it with passive true. So when you define an event as a passive event by giving it passive true, you're explicitly telling the browser, I will not call event.prevent default. So now the browser can immediately pass this event and handle it without waiting for your callback. So, and even if you call event.prevent default, it will just not work. So that's an excellent way to make scroll fast on mobile. And I've read an article that in Chrome 56, this will be a default for some touch events on the window and the body. So even if you do not define it, it will be a default. But of course, you have to define it for other browsers to work, like Safari and Firefox. So this works today on Chrome, Firefox, Opera, and Safari Technical Preview. And let's see, you can actually defer non-essential work by using request idle callback and a callback function. So request idle callback allows you to, if you're sending analytics or if you're doing something that you don't want to affect the main thread, you'll be able to do it in small chunks. And this is something that the browser will call your function whenever it sees fit. So for example, it will call it before a visual sync. So when the browser is working on a frame, it's finished everything in less than, say, 12 milliseconds, and the browser knows it has like 10 milliseconds 10 millisecond spot. It will run your code for 10 milliseconds. And that's a good way to guarantee that whatever heavy work you're doing is not affecting the UI. So this works on Chrome today and Opera. Intersection Observer is my favorite, although we're probably not going to use it a lot, but it allows you to ask the browser to notify you whenever the viewport, whenever the user scrolls into a particular viewport. So that will make scrolling much faster because we don't have to poll on scroll events anymore. We don't have to ask the user, did he reach this location? Did she reach this location every single time? So you just ask the browser, you offload it to the browser, and you'll just get a callback. So this works on Chrome, Opera, and Edge today. And CSS containment is exciting, especially if you have like a lot of widgets. In the example on the right, you are able to constrain or to limit the layout changes of a particular div to the div itself. So previously, if you loaded a certain widget and this widget needed to recalculate layout, which is something internal to the browser, the browser had to recalculate the layout of the whole page. So now you can give it some constraints and say whenever it changes layout, it's not going to affect the rest of the page. So you're more specific, the browser has to do less work, which means more performance. And this is on Chrome and Opera today. And the payment request API is also exciting. It works on Chrome for Android and Edge. And this shows a native UI to get payments. It handles also addresses, so you can configure it with other providers like Stripe, Braintree, etc. It's not in payment processing, it's only the UI. So it shows a native UI, uses saved credit cards, and basically forces the user to type less, which is a good thing for us if we want high engagement. So it also manages shipping, payments, and addresses. So everything I talked about up until now works at least in one browser, but in a stable browser. But what I'm going to talk about now is what I think and what other people think is the future of the web. So this is where you have to use Chrome Canary, possibly some flags. How many of you have heard of WebAssembly? All right, so WebAssembly is a cross-browser, low-level language, and it unlocks an entirely new set of web applications because you are able to run some particular code in native language. It doesn't mean we're rewriting the whole web to be native. That's absolutely not correct. I'll show you a test.webassembly, which is a WebAssembly compiled code that just adds two numbers. So it adds two numbers, the first number and the second number. And I'll show you how to use it. So you'll need Chrome Canary for this. Last week it needed a flag, but as of a few days ago, it doesn't need a flag anymore. So I'm creating an async function, WebAssembly demo, and then I'm loading the binaries. This is the same test.webassembly. I'm converting it to bytes, and then creating a module out of it, and then creating an instance. This is a little bit similar to classes and instances, a little bit. And then I console log exports and console log the result of add 2, 1, and 3, for example. And when you call this function, what do you get? So add2 here is a native function. This is native code running. And I know you don't see the benefit of adding two integers using native code, but this actually unlocks the future app model, which is a progressive web app can do some heavy lifting in progressive web app in order to do virtual reality, image recognition, encryption, science or data virtualization, image and video editing. So you will be building the same thing in a progressive web app, but in case you needed something that can only be run in native code, then you'll be able to use WebAssembly to achieve this. And this one is not on any browser. There are like so many specs about it, but I'm personally very excited about it, which is web navigation transitions. So there's a possibility that on the web, you'll be able to listen to page leave and page enter events and do some transitions. So which means you will not have to re-implement, frameworks will not have to re-implement routing in JavaScript. There will be no need for routing anymore because if you go to another page, you're technically literally going to another page. You don't have to build like a single page application. But this is not anywhere, probably not anytime soon. All right, so now I'm going to live code the progressive web apps bits and pieces. Do you have any questions so far? Cool. All right, so I prepared this here, and I'm going to use Visual Studio Code. And I'm going to run serve. So this is just like a similar to Python simple server. And if I go to localhost port 8000 here, this is the app that I already built before the talk, so I'll show you. All right, and that's it. Just before we start, I want to see how many network requests I'm using. So if I refresh, I actually get quite a lot. Has anyone stumbled upon this issue in Chrome? Like you're trying to debug and then suddenly you've got tons of JavaScript loading. Anyone? So those are actually the Chrome plugins. And the reason why I'm telling you about it is because they will skew your results. So you'll have to use incognito or maybe another profile. So I'll go on incognito this time, refresh, and that's it. Those are the only network requests that I'm doing. So now let's go to Visual Studio Code and show you what I've already written before. This is the index.html. I have the responsive viewport, meta viewport. I have some inline styles for the app shell. So actually the same one I showed you in the talk. Floating action button, logo, etc. This is the shell header, and then I have the logo. Once again, floating action button and the image. I have a speakers list div that is empty. And I'm asynchronously loading CSS. There is a better way to asynchronously load CSS, but it's not working on all browsers yet. That's why I didn't tell you about it. And loading a script asynchronously as well. So let's see what we have inside app.css, just basic styles for a card. And inside app.javascript, I have a boot function which uses the fetch API. Now, you cannot use fetch API if you have to support Safari. I'm just using it here to show you how it works, which is normally used inside service workers. So do you know JSON placeholder.type code? This is like a sample API that returns a list of users. So after returning a list of users, I'll convert the response to JSON. Then once we have the data, I will loop over it. And I'll just wrap every person and inside a card. And then at the end, I will add it to speakers list. So nothing major, but I'll use this demo to explain how you can build a progressive web app. And I'm calling the function here. All right, so the first step is obviously to work on the manifest.json. I already prepared one here. I gave it a name, NDC London. This is going to show up on the desktop, on the home screen. This is the short name on the home screen. The name is going to show up on the splash screen. I set the start URL to index.html, and I want to know my users are running from the home screen. Display standalone, which is going to hide the UI from the browser, background color, theme color, etc. So now we have to go to index.html and link to it. So I'll scroll up and link to it here. So link relationship manifest and manifest.json. And don't forget about the theme color. So I'm going to copy the same theme color from here and add it as a meta and give it the same color. So now how can we know if it works without actually going on mobile and testing? This is where Chrome DevTools come in handy. So you refresh and go to Application tab. This is where we have the manifest section. And you can see the browser parsing your manifest.json, warning you of potentially invalid stuff you put here. So this is a nice way to immediately test it without having to deploy, to run it through a validator or whatever. And don't forget that you should actually specify icons from, I think, 44 pixels until 198 pixels. You have to specify like 6 options. And if you want to know what are those default values, just search for web app manifest. And you can use either the Mozilla Developer Network or Google Web Fundamentals. They have excellent resources. Here. OK, so that's the first step done. Now the next step is, if I go to the network and enable 3G throttling, enable network throttling. So normally you have to test on 3G, but because I'm testing with super small files, I'll go down to GPRS. But normally this is too much. So I refresh. And before refreshing, I want to clear everything. So you can see if the content is loading or not. OK, so I'll refresh now. And it takes a bit of time to show everything on the screen. And if I go offline, obviously, it just doesn't work because it's not a progressive web app yet. So we're going to install SW precache and go through the same step to make it as a progressive web app. So the first thing that I'm going to do, in the same directory, I'm going to create it doesn't matter where you create it, a precache config.javascript. And inside this precache config, I'm going to module.exports, list the file that I want to be precached. So what do I want to be precached? Index.html. we can say CSS app.css, and let's say JS app.js. So now you can also say all the images inside the images folder. Just make sure that you're not really caching stuff that you don't need part of the app shell or later on during your app. So make sure you're not like caching all the images in your website. And that's it. So let's go run sw-precache and then pass in the configuration file. So just pass in the configuration file and it's going to generate the service worker code for you. That's it. So you can pass debug as well, or verbose to understand what's being cached or not. But those are the same things you listed in the manifest. All right, so how does it look like? That's it. A lot of disclaimers. And the reason why SW precache is better than us writing our own code is that it stores a hash for every single file. So if you're shipping a new version of Service Worker, but you didn't make any changes to index.html, it will not remove it and add it to the cache again. So it's an optimized way. And all of this code for it to run. So now the next step is to register the Service Worker. So I'll go to the landing page, to the index.html, create a new script tag, check that there is Service Worker support in Navigator. And then register this Service Worker. You can also add .then, make sure it's working, .catch. So now, let's go back, refresh. We have to go online, of course. No throttling. So we go online, and we see the Service Worker is actually here. Whenever you see the gear, it means there's a request coming from the Service Worker. And if you go to the Application tab, Service Workers, this is our Service Worker installed. And it's managing this page. That's cool. Let's refresh one more time and go into cache storage, SW precache. Those are the resources that we cached. So what does it mean? Now, if we go to Network tab and enable GPRS and refresh, the app shall load super fast, reliably, but not the dynamic content. We're going to fix this later on. And once again, if we go offline, we will get the app shell, but we will not get the content inside of it. So now, before we continue fixing things, I was telling you about the home screen equals 1 requires a particular fix. Because by default, SW precache only ignores UTM in the URL. So I will go back to SW precache config. And this is the default, by default. So whatever starts with UTM, so starts with UTM, and I'm going to add my own, which is whatever starts with home screen. So we want to ignore this so that it can be returned by the cache. And every time you change something in the index.html or any file that is pre-cached or the service worker configuration, you have to rerun SW precache. So what normally happens is you put SW precache as part of your build tool. But now I'm not going to automate it, so I'm going to keep on running it manually. All right, so let's go ahead and configure runtime caching. So I just specify runtime caching, and I need to specify a URL pattern. This is where you put a regular expression. So I'm going to get it from app.js. You have to exclude the HTTP or HTTPS, and you have to escape things. So this is a regular expression. You have to escape the slash. You have to escape the dot and wrap it with a slash and a slash. That's it. So whenever the URL matches this pattern, which handler am I going to use? Let's say cache first. So the first time it's going to go to the network, and then subsequent requests will use the cache. So now we have to rerun the service worker code, this SW precache, go back to the page, refresh. This is where the new service worker is taking control, is actually running. So on the next network request, it will actually be taking control. And you can see here that the service worker is requesting, this is how the gear icon, is requesting the list of users. So which means we now have it in the cache. Let's double check. We go to cache storage and SW toolbox. We have the list of users here in the cache. That's great. So now we go to the network, go offline or go to GPRS, refresh, and we are still able to return stale content. So this is much better than showing like a dinosaur image that the app doesn't work. I still have time to show you one more thing, which is what if we use the fastest strategy? If you use the fastest, which is stale while revalidate, I'm going to rerun the service worker code again. So refresh the first time. This is where the new service worker code is being fetched. The next time is where this service worker is actually managing the page. And let me see if I can show it to you here. Let's refresh. Users, actually, I need to throttle to show you this. Okay, so that's it. This is the user's request. It's going through the service worker, but it's returning super fast. That's because it's returning from the cache. Whereas the service worker itself is actually requesting users from the network, and once a request has come back, it will update the cache. So just to visualize fastest. I know it's a little bit hard to visualize because you're seeing the main thread and then the service worker at the same time. So do you have any questions so far? That's it for the live demo. All right. Actually, let me show you one more thing. If I go back to cache first, and let's say I change the background color for this to red. If I use red, and now obviously you have to rerun the service worker code, so that's why you'll have gulp or webpack running all the time. Go back, refresh. So the first time you refresh it, you'll be serving from the cache, so you will not get the updated version to the app shell. But the next time you refresh, sorry, right now you're getting the updated version. Did I save? Oh, sorry, it turned red. I didn't notice it. So you will not get the updates from the first time. You'll get it the next time. And this is fine if you're updating the app shell. There are like multiple strategies to deal with this. So let's take a few minutes, and if you've got Android, you can go to this URL and try the exact same demo that I showed you right now. I already coded it and uploaded it to GitHub, so you can go to bit.ly ndc-london-demo. So you'll get the same website. You'll be able to add it to your home screen. Just make sure you have Android or like Nexus or Samsung tablet. Yes? So the question is, what can we do to support iOS in terms of user interface or in terms of PWA? Because there's no PWA support in iOS. Yeah. Okay. Well, there's brief positive signal in a 5-year plan, but there isn't something more concrete on that. Chrome engineers have been saying that Apple engineers have been giving feedback on the spec, which means they're looking at it, but nobody knows when it's going to roll out. Yeah, the service worker is not going to work. Now, what some websites like Flipkart has been doing, I think they're caching the stuff and like manually checking the cache, manually checking for network failure. But this is going to be a hassle if you're going to have to do it. All right, so those are the list of resources. You can take a look at other progressive web apps on pwa.rocks, which is managed by Opera developer relation teams. Google Web Fundamentals and Mozilla Developer Networks have excellent resources for progressive web apps, and especially service workers. So make sure to check them out. So I hope you enjoyed this talk. Thanks for your time. You can find this presentation online here, the same link as before, but without the dash demo. You can also follow me on GitHub, and I'll answer your questions right now and even after the talk if you like to. Thank you.